Hello guys, this is Ahmed and this is the fourth class explaining Visual Basic for A level 9618. Okay, today we're going to speak about calculations, and we are going to try to use arithmetic operations like addition and multiplication. So for use for the most of you, I think this is quite easy. But just in case that somebody is not clear with the concept, so here we are actually defining and declaring variables number one, number two, both as integers, and then we also declared another variable that is called sum also as an integer, and then we use product. So these two will actually carry our results. So if you can see here that our variable naming is quite important because it can tell us even before we look into any of the arithmetic operations here, we are able to detect this sum is used for what. So typically this is an addition, this is a result of an addition, and product, this is the result of multiplication. So we take two numbers here from the user. So we prompt the user to actually enter a number, and then we read line, which means that we take an input from the keyboard of the user, and then we store that into number one, and we do the same here. We store the input of the user in number two. So it means that we already have two numbers here, and then we do an addition or arithmetic operation of adding two numbers here, and then we store the result into some variable, and we do here multiplication, and we store the result in the product variable. So the point here that if you can notice that we do the declaration here alone, and then we do the assigning not only a final number, just we do any arithmetic operation. So it means that the variable here, it doesn't need to be actually, you don't need to really just put a value like that. So it's possible to actually have even multiple arithmetic operations, and the computer will actually do this arithmetic operation first before getting the result and storing it in the variable, like the sum and the product. So both actually work the same. So are we limited to only addition? No, we can actually do multiplication and division all in the same line, and the computer will actually perform all this arithmetic operation before he assigns the result into the variable on the left-hand side. Okay, so after we already have some values stored in sum and product, then these four lines actually will print the result of, not the result, but the content of the variables in the memory. So if you see here, I already run this program, and I already entered number one as 10, number two as 20, and then I add both, and the result is 30. So it means that it seems to be correct. It's doing the correct thing here. And the product is actually 200, which means that we already successfully managed to multiply 10 by 20. Okay, so let us have a look at something a little bit more advanced. Let me try to clear the screen here. Maybe I try to use the red so it can make some difference here. Okay, so here we're going to look actually from here. So from here, actually, we're going to look how we are able to raise a number to the power of, so this is an exponent, so we're going to raise the number 2 to the power of 3. So 2 to the power of 3, this is how we write it in Visual Basic, and we are going to print our result to confirm that it is okay. So if you can see here, the dead, when it is printed, it brings us 8, which it seems that it is actually correct here. If you can see, 2 multiplied by 2 by 2, so it means that it's 8. And Okay, another example here that we're trying to do, which is integer division. So integer division is actually different from the normal division. The normal division would be something like that. So if you divide 10 by 2, it will give you 5, but integer division is something actually different. So if you have a number that you expected when it is divided by another number to give actually a decimal result, a result with a decimal point. So what we want to say here that we would like to ignore all the number after the decimal point and only get the integer part of it. So if you can you imagine if I divide 11 by 2, so it will give me 5.5. So if I do this integer division, which is like that, so I will only get 5. So it means that I get the integer portion and I totally ignore the number after the decimal point. So if you can look here, when I divided 23 by 5 on an integer division, so the result for me was actually 4. So why 4? Because, okay. So the point here that we got 4 point something. So if you can see that if you multiply 5 times 4, it gives me 20, right? And if we divide 23 by 5, so it gives me actually a decimal point. Let us confirm that from the calculator. So if I divide here 23 divided by 5, so that will give me actually 4.6. So the computer actually ignored the 0.6 here and actually stick to showing me number 4, which is appearing here. So this is if you want to ignore the decimal point. So it means that we actually defined k as an integer, so it cannot really store any decimal point. So we do an integer division so that we totally ignore the decimal point here, 0.6. Okay, now we talk about modulus. So in the modulus, we're going to actually see something that is slightly different from even integer division or normal division, but it is slightly related to division. So I would say that if you would like to get the remainder of a division, so the only way to do that is to use the modulus. Modulus is very, very important. You are able to actually use it in many if statement if you want to know the number is odd or even. So that is the way to go. If you would like to even know, would like to know that if a number is a multiple of another number, so you also need to do to use modulus. This is the only way to also do it. And so we will see here that if I want to know, okay, let's not speak about odd and even now. Let's speak about the normal division. So if I divide 20 by 6, so it means that we're going to get 3 point something. Okay, so this 3 point something, this means that this is an integer part and then there is a decimal point part. Let me try to divide it to know the exact result here. So if I say 20 divided by 6, it gives me 3.33. So but the point here, I don't really care about the 3 here. So this is the normal division. If I use modulus, okay, and the modulus here is referred by MOD. See, if I say 20 modulus 6, it will actually give me 2. So why 2? And what is the relation between 2 and this is decimal point 33? So the point here that if you want to know the remainder, I would say that we would try to look to the multiply 6 by a number that will give me a number that is smaller than 20. So if we try to multiply 6 by 4, so this is give me 24. If I try to multiply 6 by 3, it gives me 18, and 18 fits my my point here. So it means that the nearest number to 20 is actually 18. So if I multiply 6 by 3, it gives me 18. I subtract 20 minus 18, it gives me 2, says the remainder is 2. So if I divide 20 by 6, the result is 3, and the remainder is 2. Okay, so that's why when you do 20 modulus 6, the result here is actually 2. So what if you say that you put 18 modulus 6 in this case? So if we put 18 instead of 20 modulus 6, so the remainder will be 0, because 18 can be actually divided by 6, and it doesn't have any remainder, so it gives us just immediately 3 without even any decimal point. So we can even try to do that here. So if I change here to make it 18, or yeah, like that, so I would say that the result would be, so I enter the first number, I enter the second number. This is needed for the input above, of the multiplication and the sum above. So, okay, let me try to clean a bit here. As you can see, the I result, which is the one that we care about, okay, here, the I is 0. Why? Because when we divide 18 by 6, actually the remainder is 0. So if I say 18 modulus 6, so the result is actually 0. So, okay, that is one thing. Second thing is that if I want to know a number is odd or even, so if I put here any odd number, so x is an odd number, and this portion, y, must be always 2 if you would like to know that x is an odd or even number. So to recognize x is odd or even, we always put y as 2. So we will run here again. We will put our numbers like that, like this. And then as you see, the result here, I equal 1. So when I printed I, it gave me 1. Why? Because 21 is an and it's an odd number. Okay. If I would put actually this as 100, so you will see that the result of this operation actually is 0, because if you divide 100 by 2, it gives you 50, and it doesn't have any decimal point, or doesn't have any remainder. So that's why the result will become actually 0. So if this is end of our current video. We will try to make it short videos. If you are watching these videos and there is something that you don't understand, or something you want me to do, you want me to move faster or even slower, please write to me below in the comment section, and subscribe to the channel. Okay, see you next class. Bye-bye.